The star that ate Saturn. If you replaced our sun with this star, Earth wouldn't just be inside it. Mars would be inside it. Jupiter would be inside it. Saturn would be inside it. Your brain isn't built for this. Humans evolved to judge the size of fruit and the distance of predators, and everything that follows will break that wiring. The star is called Stephenson 218, and it's the largest known star in the universe. Its radius is roughly 2,150 times the radius of our Sun. And somehow, the star that held the record before this one turned out to be less than half the size everyone thought. UY Scuti was widely reported as the biggest star for years, but when the Gaia satellite measured it properly, its radius dropped to about 755 solar radii, barely half the old estimate. So how big is Stephenson 218 really? Our Sun fits about 1.3 million Earths inside it. Stephenson 218 fits about 10 billion suns inside it. If it sat where our Sun is, its surface would stretch past Saturn, and a spacecraft traveling at light speed would need over 3 hours just to circle it once. Trying to picture this is like trying to picture $1 million, except every dollar bill is also a star. And that's section 1. We haven't even left the category of individual objects yet. The factory wider than 1,000 solar systems. Every star you've ever seen in the night sky was born somewhere. This is the biggest somewhere we know of. It's called the Tarantula Nebula, also known as 30 Doradus, and it sits in the Large Magellanic Cloud, a small galaxy orbiting our own. It's so luminous that if it were as close as the Orion Nebula, it would cast shadows on Earth. Despite being a nebula, which sounds delicate and wispy, this thing is churning out stars at a rate that makes our galaxy's star formation look like a hobby. The Tarantula Nebula stretches roughly 1,860 light-years across, and it holds about 1 million solar masses of gas and dust. Inside it are some of the most massive and luminous stars ever found, including R136A1. Now, the Orion Nebula, the most famous nebula visible to the naked eye, is about 24 light-years across. The Tarantula Nebula is roughly 78 times wider than that. 1,860 light-years. You could line up over 1,000 solar systems end-to-end across it. And inside this cloud, the radiation from young, massive stars is intense enough to sterilize everything within a significant radius. So it's a nursery and a death zone at the same time. A cloud of gas and dust, and it's wider than anything the human species will ever physically cross. The black hole bigger than our solar system. You could drop our entire solar system into this black hole and it wouldn't notice. Scientists didn't even think black holes could get this big. It's called Phoenix A, and it contains approximately 100 billion solar masses, making it the most massive black hole ever directly measured. It sits at the center of the Phoenix cluster, about 5.8 billion light-years away, and its event horizon, the boundary where nothing escapes, is larger than our entire solar system. Black holes aren't literal holes, by the way. Phoenix A's event horizon is a sphere, and at this scale, it's a sphere larger than the distance from the Sun to Pluto and back. The black hole at the center of the Milky Way, Sagittarius A star, is about 4 million solar masses. Phoenix A is 25,000 times more massive than that. 100 billion solar masses. That's roughly the mass of an entire galaxy, compressed into one object. If you sent a probe to study Phoenix A, the probe's last useful transmission would be, "It's big," before the data stopped making sense. This single object contains roughly as much mass as the entire Milky Way galaxy. One object. One very bad object. 100 billion suns, and not a single photon gets out. The universe doesn't just build big. It builds big and then keeps going. The galaxy that swallowed everything. Our Milky Way has somewhere around 200 billion stars. That's a big galaxy. This one has 100 trillion. It got that way by doing something that would terrify every galaxy in its vicinity. It's called IC 1101, and it's the largest known galaxy, estimated at 4 to 6 million light-years in diameter. It built itself through billions of years of galactic mergers and cannibalism, absorbing smaller galaxies over cosmic time. IC 1101 has been eating other galaxies for billions of years, and its reward is being an elliptical galaxy, which in astronomy means round, featureless, and kind of boring to look at. The Milky Way is about 100,000 light-years across, a big galaxy. Andromeda is 220,000 light-years, bigger. IC 1101 stretches up to 6 million light-years. You could fit 60 Milky Ways across it. It contains roughly 100 trillion stars and is about 2,000 times as massive as our galaxy. It has 100 trillion stars, and from Earth it looks like a faint blur. The universe has no sense of presentation. 60 Milky Ways across, and it took us until 1990 to even measure how big it was. 300 million light-years of nothing. What if you traveled for 330 million light-years and found almost nothing? Not less than expected, almost nothing. Remember when a star the size of Saturn's orbit felt incomprehensible? We're not even close to done. When astronomers first discovered this region, they called it the Great Nothing, and what's inside it is even stranger than what's missing. It's called the Boötes Void, and it's approximately 330 million light-years in diameter, one of the largest known voids in the universe. Robert Kirshner discovered it in 1981 during a galaxy redshift survey. It contains only about 60 galaxies, where roughly 2,000 would be expected. Voids aren't actually empty though. Boötes has 60 galaxies, but for a region that size, that's like finding 3 people in a country that should hold 100. The distance from the Milky Way to Andromeda, our nearest large galaxy, is 2.5 million light-years. The Boötes Void is 132 times wider than that gap. Imagine being on a planet inside the Boötes Void. Your night sky would be almost completely black. No Milky Way, no nearby galaxies, just darkness. Light leaving one side when dinosaurs went extinct still hasn't reached the other side. 330 million light-years of the universe just deciding not to show up. And if any of this is making you want to learn more about what's out there, I put out content like this on a regular basis. Subscribing really does help, and I'd appreciate it. Thanks. Our cosmic address. You have a street address, a city, a country, a continent, but your real address is much, much longer than that. The supercluster we live in is so large that the Milky Way is just a speck on its edge, and we didn't even know it existed until 2014. It's called the Laniakea supercluster, and it's approximately 500 million light-years in diameter, containing roughly 100,000 galaxies. R. Brent Tully and his team at the University of Hawaii defined it, and they named it Immeasurable Heaven in Hawaiian. We named it Immeasurable Heaven, and we're a speck on its outermost fringe. That's like naming an ocean after a barnacle. Our local group, the Milky Way, Andromeda, and about 80 smaller galaxies, spans roughly 10 million light-years. Laniakea is 50 times wider than our entire local group, 500 million light-years across, 100,000 galaxies, and we're perched on the very edge, near the local void. Everything you've ever known, every person, every civilization, every star you've ever seen, is one galaxy in 100,000. On the edge of a structure we only just noticed. 100,000 galaxies, and we named the whole thing from a rock on the outskirts. The quasar wrapped in a galaxy-sized cloud. Most black holes are invisible. This one is surrounded by a glowing cloud of gas larger than the Milky Way. Twice as large, actually. The thing powering this cloud is so bright that it outshines entire galaxies from 10 billion light-years away. It's called TUN 618, a quasar powered by a 66 billion solar mass black hole. Surrounding it is a Lyman Alpha Nebula, a cloud of glowing hydrogen gas, at least 330,000 light-years in diameter. The nebula has 2 parts, a stream of gas being blasted outward from the center, and a massive cold gas cloud surrounding the whole system, each containing roughly 50 billion solar masses. The Milky Way, our entire galaxy, is about 100,000 to 200,000 light-years across. TUN 618's nebula is 330,000 light-years, wider than our galaxy. The gas surrounding this one quasar weighs 100 billion solar masses combined. That's a galaxy's worth of material, just floating around one feeding black hole. The nebula is twice the size of our galaxy, and it exists because one black hole is eating so aggressively that it's illuminating the gas around it like a cosmic lamp left on. Ton 618 has been demolishing its surroundings for so long that it accidentally created something more impressive than the galaxy it lives in, a single feeding black hole, wearing a cloud bigger than the Milky Way like a halo. Everything we've covered so far fits inside something larger. That's not a coincidence. It's the architecture, the skeleton of the universe. Every galaxy, every cluster, every void in the universe, they're all stuck to the same invisible web. At this scale, individual galaxies are rounding errors. In December 2025, astronomers found one strand of this web that's 50 million light-years long, and it's spinning. The cosmic web is a network of filaments, walls, and voids spanning the observable universe. Filaments are the largest known structures, threads of galaxies and dark matter connecting everything. That spinning filament, discovered by an Oxford-led team, contains over 280 galaxies, with 14 of them rotating in sync. That synchronized spin challenges models of how cosmic structures influence galaxy formation. Scientists discovered a 50 million light-year structure is spinning, and their immediate reaction was basically, that's not supposed to happen, followed by years of trying to figure out why. A single galaxy cluster might be 10 million light-years across. A single filament of the cosmic web can stretch 50 to 200 million light-years. The entire cosmic web spans the observable universe, billions of light-years of interconnected threads, and we've only mapped a fraction. We live on a planet, orbiting a star, inside a galaxy, stuck to a filament, woven into a web that spans the entire known universe. And we figured this out from the surface of the planet. The universe has a skeleton. We're just one cell stuck to one bone. The Titan we just found. In January 2025, astronomers announced they'd found a structure so large it contains nearly half of all galaxy clusters in its region of space. 5 new superstructures were discovered at once, and one of them dwarfed the other 4 combined. It's called Quipu, named after the Incan recording device, a system of knotted strings. We named a structure containing 200 quadrillion solar masses after a bundle of knotted string. Astronomy naming conventions are undefeated. Quipu stretches approximately 1.3 billion light-years across, and was declared the single largest known structure in the universe upon discovery. Together with 4 other newly discovered superstructures, these 5 contain 45% of galaxy clusters, 30% of galaxies, and 25% of all matter in the observable universe. Laniakea, our home supercluster, is 500 million light-years. Quipu is roughly 2.6 times wider, 1.3 billion light-years. A quarter of all matter in the observable universe sits in just 5 structures, and Quipu is the biggest. This thing was sitting in our data the whole time. We just needed to look at a big enough chunk of the universe at once to notice the pattern. 200 quadrillion solar masses, hiding in plain sight until 2025. The arc that broke the rules. There's a rule in cosmology. On large enough scales, the universe should be smooth and even. This thing breaks that rule. At 3.3 billion light-years across, it's so large that some scientists argue it simply can't exist. And yet, there it is. It's called the giant arc, a crescent-shaped arrangement of galaxies and galaxy clusters approximately 3.3 billion light-years long. It sits about 9.2 billion light-years from Earth and spans nearly 1/15 the diameter of the observable universe. The universe apparently didn't read the textbook where we said it had to be smooth at this scale. Quipu, one of the biggest structures ever found, is 1.3 billion light-years. The giant arc is 2.5 times longer. The cosmological principle, the idea that the universe looks roughly the same everywhere on large scales, has been a foundational assumption since Einstein. The theoretical homogeneity limit is about 1.2 billion light-years. The giant arc is nearly 3 times that limit. This is the most dramatic known challenge to one of physics' oldest assumptions. Imagine breaking a fundamental law of physics, and your defense is just being really, really big. 3.3 billion light-years of the universe disagreeing with physics. When structures get this large, the question stops being how big and starts being how is this even possible? The invisible mass pulling our galaxy. Right now, our galaxy is moving, not drifting randomly, being pulled towards something we can barely observe. It sits behind the thickest part of the Milky Way's disk, a region astronomers literally call the zone of avoidance. And whatever it is, it has the gravitational pull of millions of galaxies. It's called the Great Attractor, a gravitational anomaly at the center of the Laniakea supercluster, located in the direction of the constellation Centaurus, approximately 150 to 250 million light-years away. We're hurtling towards something at 1.3 million miles per hour, and we can't even properly see what it is. This is the cosmic equivalent of driving with a foggy windshield. The Milky Way moves through space at about 600 kilometers per second toward this region. It's not just us, though. The entire Laniakea supercluster, all 100,000 galaxies, are flowing toward it. And behind the Great Attractor, there's the Shapley concentration, even more massive, which may be pulling the Great Attractor itself. The Milky Way literally blocks our view of the thing that's pulling us. Our own galaxy is in the way of finding out where we're going. Something massive enough to pull 100,000 galaxies, and our own galaxy is blocking the view. The wall at the edge of everything. We started with a star that swallows planets. We're ending with something that swallows the concept of distance itself. We've built from a star, to a nebula, to a black hole, to galaxies, to superclusters, to the cosmic web itself. Every step, the scale got more absurd. This is the last step, and it might break cosmology. A team of astronomers found it by accident in 2013, buried in gamma-ray burst data. And more than a decade later, we still aren't sure it should exist. It's called the Hercules Corona Borealis Great Wall, estimated at 10 billion light-years in length, with some analyses suggesting up to 15 billion. Horvath, Hakala, and Bagley identified it by analyzing swift gamma-ray burst mission data. They noticed an unusually high concentration of gamma-ray bursts at similar distances. We found this thing by noticing that too many things were exploding in the same neighborhood. That's a very astronomer way to discover the biggest thing in the universe. The giant arc, a structure that already defies the cosmological principle, is 3.3 billion light-years. The Hercules Corona Borealis Great Wall may be 3 to 5 times larger than that, up to 15 billion light-years. The observable universe is 93 billion light-years across. This single structure could span roughly 1/6 of everything we can see. A 2020 paper supports its existence, but the Theseus satellite is needed for conclusive evidence. It might be 1/6 the width of everything that exists, and we might also be wrong about it entirely. Astronomy is a humbling field. 15 billion light-years, 1/6 of everything we can see, and we found it because too many things were exploding in the same part of the sky. If any of this gave you a new sense of just how absurdly large the universe really is, subscribing helps me keep making content like this. Thanks for watching.